The objective of this topic is to identify the basic principles and applications of magnetic particle testing.
Magnetic particle testing is a highly sensitive method used for locating cracks, porosity, slag inclusions, and other discontinuities found in welds and materials which can be magnetized. It is used extensively in the welding industry for detecting flaws in weld and base metals. The principle can be simulated by using a simple bar magnet. If a small amount of magnetic particles are placed on a bar magnet, the majority of the particles will be drawn to the magnet ends, the north and south poles. If the magnet is notched, the magnetic lines of force pass through the air, creating new north and south poles on each side of the notch. Therefore, magnetic particles will be attracted to both of the poles formed by the notch.
Using this principle, if a part is magnetized by placing it in a strong magnetic field or by passing current through it, the part will behave like the magnet. If a flaw exists on the surface or slightly beneath, it too will develop magnetic poles and attract particles, roughly in the shape of the flaw, creating an indication that a discontinuity exists at that place.
Magnetic particles can be applied using a dust bag, atomizer, spray gun, brush, and so on, depending on the type of particles used, either a wet solution or a dry powder. If dry powder is used, it should be applied evenly over the test area. Excess concentrations of particles should be removed in order to accurately inspect the surface. Because the wet solution consists of a much smaller particle size than the dry powder, it provides greater sensitivity for fine surface cracks. However, the dry powder remains more sensitive to flaws located below the surface. This test method is highly sensitive to discontinuities open to the surface, but decreases in sensitivity as the flaw depth increases. The sensitivity is most reliable down to 1/4 inch below the surface.
There are two types of magnetic fields that can be set up and used. Circular magnetization is created by passing a current through the piece, or is used to create a field in which a cylindrical part may be placed. Longitudinal magnetization passes a current around the piece to create a field through the piece. The type of field used is based on the size and shape of the test part.
The prod method is often used to create circular magnetization by walking the prods along the weld to provide full coverage of inspection. Extreme care should be taken that no electric arcing takes place between the prods and the part, as this can damage the surface. A wet horizontal testing unit can also be used to create circular magnetization, but is costly and not available in some facilities.
Longitudinal magnetization can be applied by a coil, wrapped coil, or yoke as seen here. The yoke method is the most practical and widely used, and is also one of the safest since no current comes in contact with the test surface and arcing is eliminated. A wet horizontal can also be used to create longitudinal magnetization.
Both alternating and direct current are utilized by magnetic particle testing. The current selected will be based largely on the type of equipment available and the degree of sensitivity required. Alternating current provides the least sensitivity and only magnetizes the surface of the specimen. Because it does not penetrate through the entire thickness of the part, it should be used only for locating surface discontinuities. Direct current is the most sensitive and provides a magnetic field which penetrates throughout the thickness of the test specimen, which makes it practical for finding subsurface discontinuities.
When the proper procedures have been carried out, the shape, sharpness, width, and height of the particle patterns are evaluated to determine the type of discontinuity or defect. The closer the indications are to the surface, the more defined the particle patterns will appear, whereas the deeper the flaw, the weaker or fuzzier the indication. Since many factors must be taken into consideration to make precise judgments, careful evaluation by a well-trained inspector is important. The inspector's judgment should be based on requirements specified by applicable procedures, specifications, or codes. Depending on requirements, a questionable indication may require further non-destructive testing, such as ultrasonic, and radiography.
Once all inspections are complete, concise records of the test results should be developed. A permanent record can be easily made by one of two ways. Clear, transparent tape can be placed over the indication to transfer the particle patterns to the tape. The tape can then be placed over a simple sketch of the weldment on the test report form, or a photograph can be taken of the test surface and attached to the final report.
After all reports are finished and visual inspection is complete, it may be necessary to demagnetize the part, since some components may retain magnetization and make it difficult to perform further welding. A magnetic field indicator will show the amount of retained magnetism.
In conclusion, remember that proper application of the test is based on having qualified personnel conduct the test procedure and carefully following the steps previously discussed.